The lesson topic for this video is add and subtract rational expressions, and these are the level 2 types of examples that you're going to see for this standard. Now there's not a very big difference between the level 1s and the level 2s, but what you'll see is that the numerators have binomials, and that is going to be our main difference in level 2s. They're going to be a little more challenging, and we'll have to use some additional math tools, and you'll see that as we go along with this example. Okay, so to get started here, please remember that the first thing in the adding and subtracting standard that you want to pay very close attention to is if you are adding or subtracting. And in this case, since it is subtraction, I would actually recommend that you immediately turn this subtraction sign into an addition sign, but then we need to change the numerator of our second fraction to the opposite. So we're going to add the opposite, which is like subtraction. Now if I put in this little negative sign here, that's fine, but I should put the 2x minus 3 in parentheses. So be careful with that. Alright, so now it is an addition problem. Later we will distribute this negative in. In fact, actually if you wanted to distribute that in right away, that wouldn't actually be a bad idea. So we can distribute that negative right away into that binomial factor, and we have negative 2x plus 3. Again, being very careful that this negative gets shared with both terms. So negative 2x, negative 3, which is plus 3. So be very careful with subtraction. And now it is an addition problem. Remember, when doing addition or subtraction of fractions, it is so important that you remember we need an LCD, a least common denominator. So I'm going to come over here and I'm going to remember that the first step in finding my LCD is to factor each denominator. So our first denominator is a difference of squares, x squared minus 16. So I know that this factors into x plus 4, x minus 4. Alright, and now my second fraction, we will factor first by taking out a GCF, and the GCF is 5x, and what we're left with is x minus 4. Alright, so 5x squared, I took out a 5x, I'm left with an x, and the 20x, I took out 5x, and I'm left with 4, and still subtraction there. Alright, now we are ready to write our LCD. Remember, the steps for that is to write every factor of the first denominator, so x plus 4 and x minus 4, and then we need to include in the LCD any factors of the second denominator that we don't already have. So we already have the x minus 4, so what we need is a 5 and an x. Put that in the front because normally we put monomial factors in the front. So our LCD is 5x times x plus 4 times x minus 4. Now we're ready to change our fractions so that they do have a common denominator. And when I do this, I like to extend my fraction bars. Okay. Alright, so the first denominator, I have x plus 4, x minus 4. So I'm missing the 5x monomial factors. So 5 and x I need in the denominator. And if I need that in the denominator, I also need to multiply the numerator by 5x. And right away I recommend that you put x plus 2, that binomial factor, in parentheses in the numerator. So again, notice, I multiply the top and the bottom by 5x, and 5x divided by 5x is 1, so I haven't changed the value of my fraction. I need to do the same thing over here. I have 5x and x minus 4. I'm missing the x plus 4 factor, so I'm going to put an x plus 4 in the denominator, and I then need to multiply the numerator by x plus 4 as well. Now remember, we changed this to negative 2x plus 3. If I put that x plus 4 next to it, I should also put parentheses around my negative 2x plus 3. Alright, so now we have a common denominator and we're able to add our fractions, but the first thing we're going to do here is we are going to deal with our numerators. And just like in the level 1s, here we're going to distribute that 5x as needed there. So 5x times x is 5x squared. And then we have plus 5x times 2, which is 10x. So again, distributing in this, we get this. Again, if it helps to cross out what we're not using anymore, you can do that. Now, this is why a level 2 question is different. What do we need to do right here? Okay, we need to FOIL. If I could spell FOIL. Here we go, F-O-I-L. We need to do the first, outside, inside, and last terms in multiplication to help us simplify our two binomials being multiplied together. So, again, F stands for first. We're going to multiply negative 2x by x. So that is negative 2x squared. And then our outside terms, are negative 2x times 4, so minus 8x. And then the inside terms, which is 3 times x, so plus 3x. And our last terms, which is 3 times 4, so plus 12. Again, we're done with this. And now we can add our fractions finally. All right, so we're going to add this plus all of this. We can write it out. We could combine like terms at the same time if you're comfortable with that, but you might want to carefully write all of it down first. So that's what I'm going to do. So 5x squared plus 10x from the numerator of my first fraction plus negative 2x squared minus 8x plus 3x plus 12 from the numerator of my second fraction, all divided by the LCD of 5x times x plus 4 times x minus 4. Whew! All right, so let's simplify this. Okay, this FOIL business might be in my way, so let me go ahead and see if I can fix that. Cover that up now. Maybe. There we go. All right. So, combining like terms, we have 5x squared and negative 2x squared, so that is 3x squared. And we've got 10x is here, negative 8x is there, and another 3x is here, so that is 5x, so plus 5x. And then lastly we have this 12 as our constant. In the denominator we have 5x times x plus 4 times x minus 4. So, are we done? Well, we have to check one last thing. Can the numerator be factored? Since we have a 3 out in front here, we can try out the magic number process to see if we can factor the numerator. 3 times 12 is 36. So 36x squared is 1x times 36x, or 2x times 18x, or 3x times 12x, 4x times 9x, 6x times 6x. Are any of these factor pairs going to help us arrive at positive 5x? And the answer is no. Okay, the 4x and the 9x will not get us there because if we add them, we get 13x, not 5x. So, we are done. This is our final answer. Okay, so one more example of the level 2 types of questions that you will see for the standard. All right, so we are trying to add these two fractions. In order to add these two fractions, we need to first find an LCD. To find an LCD, we need to first factor each denominator. If you'd like to pause the video, factor those denominators, and then check back to make sure you're on the right track, that'd be a great step here. When we factor the first denominator, we should have x minus 2x plus 4. And when we factor the second denominator, we should have x minus 2x plus 3. All right, now we'll go ahead and write our LCD. We will write every factor of the first denominator, x minus 2 and x plus 4, and then include in our LCD any additional factors of the second denominator that we do not already have. We have x minus 2, but we do not have the x plus 3. All right, now we have our LCD. And now we need to make sure that both of our fractions have that LCD as their denominator. Now remember, we're done with that expression and this expression since we factor those. We can try to simplify the work a little bit. All right, this first fraction, we have x minus 2 and x plus 4. We're missing the x plus 3, so we need to multiply by the factor x plus 3 on the top, or on the bottom, excuse me, as well as in the numerator. When we do that, I would highly recommend that immediately you put the x minus 3 in parentheses as well. On the right-hand side, we have x minus 2, we have x plus 3, but we're missing the x plus 4. Including the x plus 4 in the denominator here means I also need to include the x plus 4 in the numerator here, and again put the x plus 1 in parentheses. Now, what we'll need to do at this point, since they have a common denominator, we can add our fractions, but we will not be able to add the numerators until we have simplified them, and this time it's not by distributing, but by using FOIL. So first, outside, inside, last, we'll need to multiply all the terms of each parenthesis and get our expanded form here. So I'm going to go ahead and FOIL in the numerator. I get x squared minus 3x plus 3x minus 9, right there. And since I have like terms right here, I can combine my negative 3x and my positive 3x, and I get x squared minus 9. On the right-hand side, if I FOIL, I get x times x, which is x squared. The outside terms, x times 4 is 4x. The inside terms is 1 times x, so plus 1x. And then the last term is 1 times 4, which is 4. Again, I can combine my like terms, and I get x squared plus 5x plus 4. A common thing for students to want to do now is to factor this and factor this, but remember, that will only get you back to what you just used FOIL to get rid of. Okay, so now we are going to add our two fractions, and we're way up here and down here. Here's our LCDs. Here are the terms we need to combine. We actually don't have to worry about any of this anymore. If you want to cross that out, you can. And so we're going to combine like terms on the right, or we're going to add across the top first. Let's do that. So x squared minus 9 plus x squared plus 5x plus 4. Again, all of this added together. And in the denominator, we have the LCD of x minus 2, x plus 4, x plus 3. And I just wrote my LCD from right here. If you had written this one down here, that would have been fine, or this one. Again, any way those factors are ordered is fine. All right, now we're going to combine like terms. We have an x squared and an x squared. They're both positive, so we have 2x squared. Notice we do not have x to the 4th power. We are adding 1x squared plus 1x squared, not multiplying x squared times x squared. We've got this positive 5x right here, so plus 5x. And then we've got a negative 9 and a positive 4, which is minus 5. Again, in the denominator, we have x minus 2, x plus 4, x plus 3. Our very last step here is to make sure that we factor the numerator if possible. It would be a magic number type of factoring problem, negative 10x squared, which is negative 1x times 10x, or negative 2x times 5x. Notice, neither of these factor pairs will add up to positive 5x, so it is not factorable, and we are done.